Alright guys, quick review of what we're supposed to be learning this week. The whole goal of the week is learning how to count count the atoms in chemical formulas. So basically it's just counting atoms, and that pen is no good. So I'm going to give you some chemical formulas, and we're just going to count the atoms and the elements together. So the most basic one would be H2O. So in H2O we have the elements. We have hydrogen. The number of atoms, we would have 2 hydrogens. There's a hydrogen atom and there's a hydrogen atom, and it would be stuck to 1 oxygen atom. It would be bonded to oxygen. So we would count 1, 2, 3 different atoms, 3 total. Now, molecules. Because these 3 atoms are stuck together, because they're all bonded and stuck together, they are 1 molecule. If it was hydrogen by itself and hydrogen by itself and oxygen by itself, it wouldn't be a molecule. It would just be individual atoms. But as soon as they bond together, that's when you get a molecule, when they're stuck together. So here you have only 1 molecule. Now let's try a different chemical formula. Let's try, and I'm just making these up off the top of my head, NaCl. To draw that molecule, it would be a sodium atom bonded to a chlorine atom. And I'm not sure if y'all can see that. So the elements in here would be sodium and chlorine. So just redo that. It would be sodium and chlorine. And over there, that was oxygen. The atoms, it would be 1 sodium atom, because there's no little subscript right there, bonded to 1 chlorine atom, 1 plus 1. So there would be 2 separate atoms. How many molecules that would be? There would just be 1 big molecule, because it's those 2 atoms stuck together to form 1. So that'd be 1 molecule. If I wanted to make 2 molecules of NaCl, so 2 NaCl molecules, it would be NaCl stuck together once and NaCl stuck together twice. So there's 1 molecule, a set of atoms stuck together, 2 molecules, the second atom stuck together. So when we're counting the atoms, we count 1, 2, 3, 4 total atoms here when we do 2 NaCl, because it's saying that there are 2 NaCl molecules, molecule 1, molecule 2. We can draw it out and count, or we could do math, and math is the faster way. But if you want to do it the more, I guess, the easier way, the more precise way, I guess, you could draw it out NaCl, and then you have to draw a second one, NaCl. So that with this big number here, the coefficient, it's saying that there are 2 molecules. So if we had to count the number of sodiums, we could go 1, 2. If we had to count the number of chlorines, we could go 1, 2. Or we could just do the math and say there are 2 Nas and there are 2 Cls. Let's try it a different way. Let's do CO2. Count the number of carbons and count the number of oxygens. There's no number here, so you assume that there's 1. So it's 1 carbon and 2 oxygens. But what about in 3 CO2? That's saying that there are 3 different CO2 molecules. So it would be a C with 2 O's, a C with 2 O's, and a C with 2 O's. So here's the first CO2, the second CO2, and the third CO2. So we would count our carbons and we would count our oxygens. We could go 1, 2, 3, and then we can count the total oxygens. 1, 2, 3, 4, 5, 6. Or we can just do the math. 3 times 1 is 3. 3 times 2 is 6. So let's change it up a little bit. We're going to do more. We're going to do a chemical formula. We'll do the simple one that I did in class. 2H2 plus O2 produces 2 water molecules. So if I was to draw that out, it would be 2 molecules of H2. So here's an H2 stuck together and bonded. Here's the second H2 molecule stuck together. So 2, 1, 2. And you're going to add in an oxygen molecule of 2 oxygens stuck together. That's going to produce 2 H2O molecules. So let me draw an H2O molecule. My 2 H's and an O. But I need 2 of them, 2 of those separate molecules. So here's one H2O, here's the second H2O. On the left side, 1, 2, 3, 4 hydrogens. On the right side, 1, 2, 3, 4 hydrogens. On the left side, there are 2 oxygens. On the right side, 1, 2 oxygens. Let's do another example of counting the atoms in a chemical formula. Let's do the chemical formula for photosynthesis. When a plant makes the sugar and stuff for photosynthesis, it takes in carbon dioxide, which you guys already know that it takes in carbon dioxide. That's your formula for carbon dioxide. And it also takes in water. So 6 carbon dioxides and 6 waters, and then you add in a little bit of sunlight to help the energy to break the bonds, and that produces the sugar that is the plant's food. This is the formula for the glucose that makes the plant's food. There's my water, sorry. It makes the sugar, and also it makes oxygen, which is the oxygen that we breathe in. And we know plants take in carbon dioxide, but they send out oxygen. And what's the goal of chemistry? Remember, the goal of chemistry is to make something new. That's the whole goal. Over and over again, it's to make something new. In photosynthesis, you start off with carbon dioxide and water. The plant transforms those atoms into sugar and oxygen, and it's taking these exact atoms and turning it into sugar and oxygen just by rearranging them. So let's count. Here we have 6 CO2. We have 6 different molecules of carbon dioxide. So 1 C connected to 2 O's. That's 1 molecule. The second C connected to 2 O's. 3, 4, 5, and 6. So it's 6 carbons connected to 2 O's. Now we could do it the long way and draw everything out, or we could just do the math, and I'd prefer for us to do the math. So let's go ahead and rewrite that formula. 6 CO2 plus the water produces the glucose and the oxygen. Now remember, our main goal, even though this is a little bit of extra information that I'm giving y'all, and that's fine, but the main goal of this video is to count the atoms. So let's count the atoms right here. 6 CO2. You multiply. 6 there for carbons and oxygens. There are 6 carbons. 6 times 1 is 6. And oxygens, 6 times 2 is 12. And 6 times 2 is 12. But if you want me to prove it, rather than just quickly doing the math, we could come back up here and count 1, 2, 3, 4, 5, 6 carbons, and 2, 4, 6, 8, 10, 12 oxygens. But I'd prefer for us to do the math. We don't need to draw everything out. Here we have 6 H2O molecules. So we're going to count our H's, we're going to count our O's. 6 times 2 is 12 hydrogens, and 6 times 1 is 6 oxygens. If you wanted me to draw it out and count it, H2O molecule, 1 H2O molecule, 2 H2O molecules, 3, 4, 5, 6 H2O molecules, and we can count the hydrogens, 1, 2, 3, 4, 5, 6, 8, 10, 12 hydrogens, and 1, 2, 3, 4, 5, 6 oxygens. Over here, carbons, hydrogens, oxygens. There is no coefficient in the front, so we don't need to multiply anything. There are 6 carbons, 12 hydrogens, 6 oxygens. And in the last one, there are 6 O2s, so you just multiply. 6 times 2, there's 12 oxygens. So when there are some certain vocabulary words that we need to be aware of. The first one is coefficient. Coefficient is the big number right here. This is just what you call the big number. It's the coefficient. The subscript is sub, below, script as in writing. It's the writing underneath. So subscript is this little bitty tiny number. It's the writing that is underneath the letters. It's the bottom one, subscript. So you got to know those 2 vocabulary words. Also, you need to know reactant versus product. Reactant versus product. Reactants are what cause the chemical reaction. Reactants react. They cause the reaction. See, react, react, react. Product is what got produced. So if we go to our formula up here, you have the reactants were carbon dioxide and water. They reacted to produce sugar and oxygen for the plant, the plant's food, and then the oxygen that we breathe. So I want you to think of this as a recipe. The recipe to make sugar or food for the plants and oxygen for us to breathe, the plant has to have carbon dioxide and water, and then that produces those products. From earlier, 2H2 plus O2. This is my recipe. R is for recipe, R is for the reactants. My recipe, then it produces water, so that is the product. And you're always gonna, the recipe will always be on the left, and the product will always be on the right side, always. So remember, main goals for learning today, our main goals. 1, count the atoms in a formula. So, and in order to count the atoms, you got to know what a coefficient is, which was that big number, and you got to know what a subscript is, which was the little number. You also have to know what a molecule is, what a molecule looks like. So in CO, we'll say 6 CO2 plus H2O, you have 6 carbon dioxide molecules and 1 hydrogen molecule. You got to know what a molecule looks like. It's when they're stuck together. You got to know what an individual atom looks like. So here we have 6 molecules of carbon dioxide, but we have 6 carbon atoms and 12 oxygen atoms, so 6 plus 12. All together right here, you have 6 plus 12. That would be 18 atoms altogether. 18 atoms. But then how many elements do we have there? Carbon is an element, oxygen is an element. In this other molecule, in this water molecule, we have hydrogen and oxygen. And we only have 2 hydrogens and an oxygen atom, so we only have 3 atoms there. I think that's it for now. Let me know if you have any questions.